All right, so forces at angles. Let's go ahead and take a look at this. So this is something we actually did in class, but I wanted to make a video right now just to kind of make sure that we were all on the same page. Not everybody was in class, so we have this block. It's got a tension. It's got the weight or the gravity force. And we have, well, no friction in this case. And then we have a normal reaction force. Pointing upwards. Now, the key to forces at angles. We have to split the force at an angle into its respective components. Cosine is horizontal, and the sine component is vertical. And then we set up our equations based on these facts. So look here, we have the reaction force going up, t sine theta going up, and Fg going downwards. And that's our basis for equation. So R plus t sine theta minus Fg equals 0 is one of our equations. And the other equation is t cosine theta makes the mass accelerate. We're not in equilibrium. So our goal in this problem is we want to solve for the reaction force and the acceleration. I should have made that clearer sooner. I'd recorded an earlier version of this video and the sound didn't, there wasn't any sound, so I had to redo this. So I am pressed for time, so this is going to be a little bit quicker. So in this question, we have two formulas, and we can actually go ahead and solve. So I can take formula 1, r plus t sine theta minus Fg equals 0, and I can isolate r. So r plus 30 times the sine of 40 minus 5 times 10, remember Fg is m times g, equals 0. When we isolate r, we end up getting about 30.7 newtons. And then for the horizontal component, we have 30 times the cosine of 40 is 5 times a. That's 6 cosine 40 is the acceleration. And when we actually solve, we end up getting 4.6 meters per second squared. So that's the case where we have no friction. Now when we do have friction, we want to get, again, the acceleration and the normal force. But now our coefficient of friction is 0.2. And just to review, this is the formula for friction. If there's this little k means dynamic or kinetic friction, meaning it's moving, and then we have mu static, which is when the thing doesn't move, but there's still friction stopping it because it's trying to move and it can't. So this is the formula for friction, and we're going to be using this in a minute. So again, by the way, this little letter here, let me just label it as the coefficient, and this is the force of friction. One of my pet peeves is when students say the friction. Do you mean the force of friction, or do you mean the coefficient of friction? So use one term or the other. So force of friction is this little f here. So now we've got tension, we've got weight, we have reaction force, we have the friction force opposing motion. It is directly 100% horizontal. And then we set up t cos theta and t sine theta. One thing you'll notice, we set up our vertical equation, r plus t sine theta minus Fg equals 0. R is going to be the 30.7 from before. Now horizontally, we have a new equation, t cosine theta minus friction equals ma. That's going to be 40 times the cosine of 30 minus 0.2 times 30.7 equals, and our mass is, yes, 5 times a. So we end up getting, for our acceleration, sorry, this is 40 degrees. Sorry, this is 40 degrees right here. And then we'll divide all of this by the mass. And we end up getting 4.9 meters per second squared. Let me sure that makes sense. 4.6, 4.9, nope, something's off. So let's see. So 4 times 40 times the cosine of pi over 180. See, what would my acceleration have been before? So on this page, sorry, I had my acceleration wrong. This is 6.12 meters per second squared. And then when we subtract off the friction force, and we divide, we end up getting 4.9 on this page here. All right, so that is the example and the first problem. Now here, one small thing. We worked this out in class, but I want you to actually show me, and we can go over it together if you're still stuck. So T3, we told you, was 50 newtons. This ends up being 50 newtons, and this ends up being about 70 newtons. So that's the answer key, and I want you to prove it to me by drawing a free body diagram here. So the T3, this was given, and you want to show this. So that's it for the angled forces, and I'll put this on the solutions page right now.